Spider-Man, Spider-Man does whatever a spider.
Hey guys, welcome back to CTF Mania, and I would like to welcome you all to the series Know Your Tools, also known as KYT. And today we will not be solving any machines, but rather we will be studying about tools that help us solve these CTF machines. So without further ado, I would like to announce today's tool. As you can see from the title, it is Nmap. So before we get started, I would like to make two things clear. All the demonstrations performed here are performed on my local network, and I am not performing it on any live websites. And second one is, I would not recommend or encourage any kind of scans on any live websites, so that you guys don't land up in any legal trouble. We want to have fun, but we don't want to land up in legal troubles as well. So let's talk about Nmap. So what is Nmap? Nmap stands for Network Mapper. It is a really popular tool in cybersecurity. In fact, it is so popular that it is even used in movie scenes such as Matrix, where Trinity hacks a private network or something like that, but I don't really remember, as it has been a long time since I watched that movie. And it's actually a very important tool to have under your skills toolkit if you're looking for a job in network security or cybersecurity in general. And it's quite a big tool, but today we will be focusing on some of the important commands of Nmap so that you guys can get your basics cleared. So that's what my intention is, to basically clear the understanding of all the tools that we use during our CTFs. Anyway, let's begin with our first command for the day, which is Nmap and just the IP address. So I am using an IP address of a CTF machine that I locally downloaded, and if you guys can go ahead and see my other videos, the first video was a machine called SAR. That's exactly the IP address for SAR. So right now we have performed a scan on SAR, and as you can see, that port number 80 was open. And this scan, actually I have performed it without any root permissions. So by default, Nmap scans it as a TCP full scan. So what is a TCP full scan, you may ask? But before I dive into TCP full scan, I would like to make the difference clear between TCP and UDP. So TCP stands for Transmission Control Protocol, and UDP stands for User Datagram Protocol. So there are some key differences, that TCP is connection oriented and UDP is connectionless. And TCP is reliable, so that it makes sure that whatever data is being transmitted through TCP, it gets delivered to the particular destination. And UDP is unreliable. There's no guarantee that the packet will reach the particular destination. And in TCP, everything is delivered in order, whereas UDP does not necessarily deliver everything in order. And TCP has some error checking mechanisms included, but UDP also has it, but there is no correction over there, whereas TCP corrects it. And TCP also sends out acknowledgement. For example, if a particular request has been received, the destination has to send out an acknowledgement that I have received that particular data packet, whereas UDP does not really need any acknowledgement over there. Since there is a lot of checks and there is a lot of acknowledgements being passed, TCP is slightly slower when compared to UDP. And few examples where TCP is used is, for example, during website hosting your websites, HTTPS. Yes, it happens through a TCP connection, where a channel is formed between which there is a communication between your client and the server. Whereas UDP, one of the best examples is the video that you're watching right now uses UDP, because over here the UDP packets that are streaming the video for you are basically getting transmitted to you through the particular source. So anyway, without further ado, let's go ahead and understand a TCP full scan.
And here we go.
So in a TCP full scan, the attacker initiates a scan. So this is for the open ports. So how a target machine reacts when it has certain ports open. So for example, there is a TCP connection that TCP SYN packet is being transmitted. So SYN is basically a flag called synchronize. So it is used to start the connection between the source and the destination, which is your attacker IP and the target computer. And then after the target computer receives the SYN packet, it basically sends an acknowledgement that yes, I have received the SYN packet over here. And then after the attacker gets the acknowledgement, the attacker sends back an acknowledgement that yes, I have received the acknowledgement that you guys had sent. So over here, as you can see, this is what we call a three-way handshake. These steps that were performed are basically what we call as a three-way handshake. So what happens if the ports are closed? So if the ports are closed, the attacker sends a SYN packet, for example, and the target computer has some of the ports closed, for example. So it is going to send a packet that comes with a reset flag along with an acknowledgement. So it is going to acknowledge that yes, I have received your packet, but since the port is closed, I would like to reset the connection. So that is what happens when the TCP full scan encounters a closed port. So as you guys can see over here, this whatever process that I have explained back there in the diagrams is what has been executed over here. But what happens if I do the same scan as a root user? I'm going to perform the same scan as a root user. As you can see, there's a slight delay. Here it's scanned in 0.26 seconds, over here it is scanned in 0.29 seconds. So this, if you run your Nmap scan as a root user, you basically do something called as a stealth scan or TCP half scan. So what is TCP half scan? So TCP half scan works something like this. For example, the attacker sends a SYN packet, and then the target computer, it responds with a TCP SYN ACK, which is basically, it says that I received your SYN package and here's my acknowledgement. But this time the attacker is not going to send back an acknowledgement. It is basically going to send back a reset flag. So basically it's going to be like, you know what, never mind, let's reset the connection. So that is what is going to happen in a TCP half scan. So if I compare TCP full scan and a TCP half scan, TCP full scan is much more noisier. By noisier, what I mean is that it can be easily detected by web firewalls or network firewalls that a scan is happening, and it will be detected as a malicious traffic. So but what happens if, how does it react to closed ports? So the reaction to closed ports does not change at all, to be frank. So there is a TCP SYN packet that goes to the target computer, and then the target computer responds with a reset flag and an acknowledgement flag indicating that I received your SYN flagged packet, but there are no ports open here, so I would like to reset the connection. So that, my friends, was the difference between the TCP full scan and a TCP half scan. If you want to perform a TCP full scan as a root user, all you have to do is just go ahead and type this parameter st, and you will be able to perform a TCP full scan. And if you want to perform a TCP half scan, as a normal user, all you have to do is basically go ahead and type this command, which is ss, and then you just have to type your IP address, target IP address, and yeah, that is how it is done. So we are clear on TCP full scan and TCP half scan. Now let's go ahead and do some scans called the TCP fin scan, TCP Xmas scan, TCP null scan.
What?
So let's begin with the TCP fin scan, so which goes as SF. Sorry. So what happens in a TCP fin scan? So let us understand what these fin, sin, ac, and all what they represent. So here's a list of different TCP packet flags. You have sin, you have ac, you have fin, you have RST, you have URG, you have PSH. So sin, basically it is used in the first step of connection between the source and the destination, which is your attacker IP and your particular target IP. So as you can see from the examples of TCP full scan and TCP half scan, sin is the first packet that's always sent. So acknowledgement packet is simply flagged as ACK, which is basically used to acknowledge packets which are successfully received. And fin basically is used to request for connection termination when there is no more data from the sender. So, and then you also have reset, which is used to terminate the connection if the sender, whoever is sending RST, feels something is wrong and the TCP connection or that conversation should not exist at all. So you might feel like, you know, fin and RST are similar, but no. Fin is like initiated from only one side, whereas RST, whenever there is an RST flag, doesn't matter who sends it, it's a complete termination of the connection. And whereas fin is terminated from one side. So anyway, let's move on to urge. So it is basically used to show that the data that is there inside the packet should be handled carefully. It's like kind of like in the airport how you put a fragile sticker and then you tell that, you know, these are important goods and these need to be handled well, and over here we are just going to say that it's going to be, these need to be handled urgently. And then we have something called as PSH. So it is basically used to request immediate data to be delivered to the host. So the data needs to be delivered fast to the particular host without waiting for extra data that needs to be buffered from the sender side. So these are the basic flags that you need to know. You guys can screenshot this, make a note of this, because this will be important as we go through the videos and try to understand different kinds of scan. So we were talking about fin scan. So how will fin scan work? So at first the attacker sends packets with a particular flag already set called TCP fin. I think this has to be TCP. I have written it as TYP. Okay, anyway, so it is TCP fin scan is written, TCP fin flag is set, and it is sent to the target computer. And if the ports are open, the target computer will not give any response, because the reason being is because the target computer is actually confused as to how it needs to react.
What is going on down there?
The ports are confused as to how they need to react, so there will be no response given. Why do we use such type of scan, which is like really weird? So the answer is very simple. It is used to bypass firewall detection, or basically detection of any malicious traffic if it has been done on the target computer's end. This type of scan is used because sometimes this might slip through the detection and give us the results. But what happens if the ports are closed? What will be the reaction? So if the ports are closed, first of all, there will be a fin scan that is sent. The target computer will react the same way as it did for TCP full scan, and it did the same for TCP half scan as well. It is going to send an acknowledgement saying that the port is closed, boss. You can't get in through here. So that was TCP fin scan. Let's move on to other commands. So anyways guys, I've cleared my screen. Now I will be talking about something called as Xmas scan. It sounds a bit like Christmas, but you will know soon enough why it is called an Xmas scan. So the Xmas scan is similar to the fin scan, but only the difference over here is the flags. The reaction remains the same from the target IP, but the only thing is the flags. So what are the flags that an Xmas scan uses when it sends packets to the particular IP address? So in a TCP Xmas scan, the open ports they react in similar manner as fin scan. So basically, but only thing is the flags that are set over here are different, which is fin, PSH and ERT. So 3 flags are being set over here and they are sent to the particular target computer. And the target computer basically gives no response if there are open ports, because the target computer is confused as to how to react to these particular flags. So that is when Nmap comes up with the result saying that these are the ports that are open. But what if it encounters the ports that are closed? There's not much difference over there as well. As you can see, the TCP flags go there to the target computer, and then the target computer responds back with a reset and an acknowledgement flag saying that, hey, I received your packets, but I'm sorry, the ports are closed today, and thank you for the packets. So this is how the closed ports react to a TCP Xmas scan. Moving on, let's go and discover another scan.
Okay.
So anyway, that was the Xmas scan. Now we will be doing something called as the null scan. So basically, in null scan, there are no flags set at all. There are no flags set at all. I showed you the example of TCP fin scan and TCP Xmas scan, but the thing is, there are no flags set in a null scan, and the results are the same. For open ports, it is not going to send back any acknowledgement or anything like that, because the computer is actually confused as to what is going on. And then when it comes to closed ports, it is going to send back an acknowledgement saying, hey, I got your packets, but we would like to reset the connection as the ports are closed today. So these are some of the basic scans. Let's go ahead and explore some of the interesting commands that we can use in the Nmap. So let's go ahead and begin with some of the basic interesting ones. So I would like to inform you one thing, that when you scan Nmap without setting, just by putting the IP address, it is only going to scan the first 1000 ports. There are somewhere around 65,536 ports. Yes guys, 65,536 ports on a machine. But the thing is, when you don't set up any parameters like this, for example, -p-, you will not get a scan for the complete 6,536 ports over there. So as you can see over here, it says 9,909.
That's right. Dimmadome, Dimmadome, Dimsdale Dome, Dale, Dimsdale, Dimmadome, Dimmadome, owner of the Dimmadome, Dimsdale Dimmadome, Dale Dome, Dims Dimmadale, Dimmadale Dome, Dimsdale Dimmadome.
909 closed TCP ports, because one port is open over here. But when you look over here, it shows 65,534. Does that mean 2 ports are closed? No. Actually, the indexing of these ports are in such a manner that the first port is equal to 0, is indexed as 0. The second port is indexed as 1, third port is indexed as 2, fourth port is indexed as 3, and it goes on till 65,535. So the maximum number of ports, if we are scanning an IP that has no ports open, it will show over here 65,535 closed TCP ports. But since one port is open, it is showing us 65,534 ports. So this is about indexing of the ports and also about the ports. Now if we want to scan some particular ports, for example, I want to just scan this port. Okay, so if I do this, it's going to say that that particular port is closed, or any other port. If I scan, for example, right now if I scan 80, it's going to say yes boss, it's open. But if I want to scan multiple, like particular ports over there, if I do something like maybe 45, it's going to say 45 is closed, whereas port number 80 is open. So this is a little bit about the particular -p parameter over there. And now we can also do something called as the version addiction scan. Okay, I will just remove these, sorry. So in this particular scan, we will get information about the version of the particular services that are running there. For example, it's the HTTP service that is running there, and the version over here is Apache HTTPD 2.4.29, and we also get to know which OS is being run over there, and it is the Ubuntu OS. But if you want to scan for just to find out what OS is running over there, this command is more than enough. And this command will go ahead and tell you or try to guess that particular OS that is being scanned. I'm sorry, I think the command is -o, that's all, not S. Yeah, as you guys can see, it's already guessing over here, and it has already found out that it is Linux 4.x or 5.x. So this is the OS scan. And now I'm going to show you something called as -pn, which is called the no ping scan. So the difference between the -pn scan and a normal Nmap scan, normal Nmap full scan, or whatever you want to call it, is that in the normal scan, Nmap goes to the host and checks whether the IP is actually up or it is not up, like it's dead. But when it comes to no ping scan, doesn't matter if the IP is up or not, it will scan for the open ports.
Bravo 6, going dark.
Why? Because sometimes the normal traffic of Nmap, for example, this particular command over here gets blocked. The traffic coming from this command gets blocked by certain IP addresses as a part of their security measures. That's why they go for a quieter approach called no ping scan. So it will not go and wake the server up and ask, hey, are you running or not? So this is the no ping scan. Now, for example, what if there's a command that could run all 4 of these scans together? And yes, we do have a command like that. It's called -a, which is aggressive scan. Well, the aggressive scan is nothing but 4 scans combined together, which is your OS detection, your version detection, your service detection, and no ping scan all together. As you can see, it gives us certain details about the HTTP headers as well. So if you just want the HTTP headers detail, you can just run this separately, which is called as SC. Over here you can get the HTTP header details. That's not an issue. Okay, so that was a little bit about these commands. Now I will move on to something more interesting, commands where we can find out what kind of vulnerabilities are present over there, like common vulnerabilities. Script is equal to 1, and then I'm going to write my IP address over here, 192.168.0.112. As you can see, the scan is running. So let me explain what is going to happen here. It will scan that particular port and let us know what kind of vulnerabilities that are specific to that port are present over there. So in a minute or two, we will be able to see the results of the scan showing us any kind of web related vulnerabilities over there, because port number 80, it is an HTTP port. So HTTP port is used by mostly websites, and as you can see, it is showing us that it is vulnerable to, after null UDP Awahi packet DOS, hosts are all up and it is not vulnerable. So if it also gives us a CVE number as well, you can go ahead and check the CVE. If I go ahead and type this over here, you can see that this vulnerability has been documented before. You can go ahead and read about this, but I will not be covering that over here. And as you can see, it even checks for XSS, cross-site scripting, cross-site request forgery, DOM based XSS, and it also found out some important directories like robot.txt or phpinfo.php. So yeah, this is what this command actually does. And if you want to save the results of your command in, a text file or something like that, you can do so by using this command. So what will happen here is the results of this command are going to be stored in this particular file called vulnscan.txt. So that is what is going to happen over here. So Nmap has a bunch of more interesting scripts that you guys can check out. I will not be covering those in the video. I just wanted to show this because I found it very, very interesting, and I am 100% sure you would find these scripts interesting as well. So we can move on to the next command as soon as this result of the scan gets documented. I just want to show you the vulnscan.txt. So yeah, let's wait. As you can see, I have used the cat command to read the contents of vulnscan, and it also tells me when the Nmap was done. For example, it tells that the scan was done on May 6th, and this is the time, and the IP address was up, and it took 55.74 seconds. And so anyway, let's move on to another command. So this command right here is actually something that I was shocked to know about. So basically, this command sends decoy traffic to the target IP. So this particular command is basically used to fool the detection system into thinking that this is an actual malicious traffic. It's nothing but a decoy traffic. It's nothing. It basically is like a distraction. So attackers, what they could do is they could use multiple instances and run the same command over there to confuse the detection, and when this havoc is going on, they could slip in the actual malicious traffic and try to scan for information right there and then itself. So these were some of the commands that we are using in the Nmap. These were some of the commands, but you guys have seen me use in my videos certain commands like this. Wait, I think I have it. Sudo root kali map. Yeah, so you guys have seen me use commands like these. So the reason I use this command is because I also have the aggressive scan and aggressive scan over all ports, and I can set the rate as well. So this particular parameter here, min rate, basically tells Nmap to send 10,000 packets at one point of time. So what does this do? This basically increases the speed of the scan. This basically increases the speed of the scan and gives us faster results. So that is the only purpose I use these commands. So that's the end of the video, guys. I hope you guys got to learn something today about Nmap, because this is a tool that we will be using always to scan the services that are running on the target machines. Doesn't matter whether it is a Linux machine or whether it is a Windows machine. Nmap is the tool that scans and gives you the answers to the question as to what are the services that are running over there. So a couple of things that I would like to address right now is there are a few commands that you can go ahead and research about. There is something called as, for example, Nmap sy 192.168.0.112. so you guys can go ahead and research about this. As you can see that it doesn't even give us the result that the port number 80 is open. A hint is it uses something called as stream control transmission protocol. It uses something called as stream control transmission protocol. So you guys are open to go ahead and find out info about what exactly this protocol is and what is this parameter over here and where could it be used, in what kind of network it scans. So yeah, it's a pretty good learning as well. So that's it for the basics of Nmap. I hope you guys are clear about the concepts, and please do check out the new Instagram page that I have recently opened up for this YouTube channel. You guys can go ahead and follow that page and share it with as many buddies as possible. It's all about memes and cybersecurity, and would love for it to grow, and hopefully we could have a good cybersecurity company, a big one. So that's it for now, and we will see each other in another video with probably another CTF machine or another video about another tool, KYT. So for now, ciao guys, have a good night.